Hello everyone, let's take a look at our next problem. One base of a trapezoid is 100 units longer than the other base. The segment that joins the midpoints of the legs divides the trapezoid into two regions whose areas are in the ratio 2 to 3. Let x be the length of the segment joining the legs of the trapezoid that is parallel to the bases and that divides the trapezoid into two regions of equal area. Find the greatest integer that does not exceed x squared over 100. Okay, I hate geometry problems like this, but we're going to draw a picture because I don't know what the heck we're being asked for here until I draw a picture. Okay, so I have a trapezoid. There's one base of my trapezoid. There's the other. I'm just simply going to label this length as y, so that this one is y plus 100. As we're told, one base is 100 units longer than the other. Let's finish up the legs of the trapezoid here. The segment that joins the midpoints of the legs, so we'll call that this. These are the midpoints. Divides the trapezoid into two regions whose areas are in the ratio 2 to 3. So if this is A1 and this is A2, then A1 over A2 is equal to 2 over 3. X is the length of the segment joining the legs of the trapezoid that is parallel to the bases. Wait. Okay, let x be the length of the segment joining the legs of the trapezoid that is parallel to the bases and that divides the trapezoid into two regions of equal area. Okay, so now we have another line of length x. Let me draw it in a different color. Where the area above the yellow line and the area below the yellow line are equal. And essentially we're asked to find x squared over 100. So we're not told that I'm going to draw the picture a little bit differently because it's without loss of generality. I can assume that the trapezoid has a right angle in it. Because now things are obviously divided into, certain areas are, we have rectangles and triangles. Okay, so if I join the midpoints like that, we have A1 and A2. We have the ratio of A1 to A2. I'm going to call this H. So this is also H. And this here will be the length X. And I'll call this distance Z. Okay, so let's write out the first statement about the ratio of areas. So the area of the entire... How do I want to do this? A1 is the top part. A1 is equal to H y plus 50h over 2. Okay, so this triangle here, this distance is 50. So the area of this triangle is 50 times h divided by 2. Now we can compute the area of the entire trapezoid. Call that AT. This is equal to 2h times y plus 2h times 100 divided by 2, which is 2hy plus 100h. And A2 is AT minus A1. A2 being this area. Okay, so A2 is 2hy plus 100h minus hy minus 25h. So this is hy plus 25h. And we're told that A1 over A2 is 2 over 3. So hy plus 25h. Oh, I have a mistake. This should be 75h. Hy plus 25h divided by hy plus 75h is equal to 2 over 3. H cancels everywhere on the left. Y plus 25 over y plus 75 is equal to 2 over 3. So 3y plus 75 is equal to 2y plus 150. Y is equal to 75. Excellent. So that's very good. Will this allow us to solve for h? Will this allow us to solve for h? I don't think so, because everything will scale linearly with h, right? And so everything will scale linearly with h. So like, you know, if I double h, the ratios of these areas won't change. Okay, so let's just write out then something similar for, you know, the area above the yellow line and the area below the yellow line in terms of x and z and so on, and see if we can solve. I guess we'll be able to solve for x. I'm going to call this length, I need another letter here, w, where w plus z is equal to h. Okay, so the area above the line, oh goodness, all I really need is the area above this line, because I have the total area of the parallel of the trapezoid already. What I want to do is I want to parameterize this length. I want to write that in terms of z divided by h. Right, if I think of z as being a variable that allows me to slide this line up and down, what z is equal to h. This distance is 50. When z is equal to 0, this distance will be equal to 100. And it'll vary linearly as a function of z over h. God, I'm introducing way too many variables here. I don't think I'll need, will I need w? Maybe. Call this length u. So u is equal to 50, no, okay, so when z is equal to, when z is 0, u is equal to 100, minus z over h times 50, right? When z is 0, it's 100. When z is equal to h, it's 50. Yeah, so u is 100 minus 50z over h. Great. Now the area above the yellow line is y times h plus w plus the area of that triangle. The base is u, the height is h plus w, divided by 2. Okay. Do I want to rewrite everything now in terms of x? I kind of feel like I want to write everything in terms of z. Just visually, z is an easier variable to understand what's going on. If I can find z, if I can solve for z, I can solve for x. So I think that's what I'll do. I'll write everything in terms of z. Okay, so y times h, w is equal to h minus z. U is equal to 100 minus 50z over h. 2h minus z over 2. Okay, so that's the area above the yellow line. Once again, the total area we had from earlier is 2hy plus 100h. So this has to be equal to twice, 2 times this. Okay, so in fact what I'll do is I'll say that hy plus 50h, this is half the total area, has to be equal to this. That's what dictates the height of that, the vertical position of that yellow line. Okay. What I think I'll do is I'll factor h out of everything. Right? Things should be, like we saw earlier, things should be invariant under scaling h. So here I have 2 minus z over h times y plus 2 minus z over h times 50 minus 25 z over h. So all of this is multiplied by h, and now we get a cancellation of h. Y plus 50 is equal to 2 minus z over h y plus 2 minus z over h 50 minus 25 z over h. So z over h I will call r for, it's the ratio, it's the height, the relative height. Okay, so y plus 50 is equal to 2 minus r y plus 2 minus r times 50 minus 25r. And I know that y is equal to 75, I believe, from earlier. Yeah. Okay, so 125 is equal to 75, 2 minus r, plus 25, 2 minus r squared. Okay. 2 minus r is equal to alpha. So I have 25. Oh, I can divide everything by 25 here. 5 is equal to 3 alpha plus alpha squared. Alpha is equal to negative 3 plus or minus the square root 9 plus 20 divided by 2. I don't like that we have some ugly numbers here. I know I'm going to throw out the negative root, so I have negative 3 plus the square root of 29. That's really unfortunate. Really unfortunate that it's so ugly looking. Do I have a mistake? Well, we are, in the end, if we remember the ultimate part of this question, we have to square the value of x. So let's just keep alpha as that. So 4 minus 2r is equal to this mess. So what do I have here? 7 minus the square root of 29 is equal to 2r. So r is equal to 7 minus the square root of 29 over 2. R was equal to z over h. Okay, so x is equal to y plus u, right? X is equal to y plus u, which is equal to 75 plus 100 minus 50r. $175 minus 25 times 7 minus root 29. Wow. Oh, wait a minute. This is convenient, right? 25 times 7 is 175. So x is equal to 25 times the root 29. So x squared is equal to 25 squared times 29. What's 25 squared? 625, right? I should have known that. So x squared is equal to 625 times 29. Okay, so x squared over 100 is 181.25. Okay, so the answer is 181 according to what I've done here. This was a lot messier than I expected. There's got to be a more straightforward way of doing this by looking at the ratios of things, but yeah, I would of course go back and check my work here if I had a significant amount of time. I'm happy that I did end up getting an answer. A lot of pretty quick arithmetic went into this, so there's a lot of possible times I could have made an error. You know, when I'm presented with a geometry problem like this, I'm a fan of setting up a coordinate system, or not a coordinate system, but setting up a bunch of variables that correspond to all the lengths, and then just simply writing out mathematical statements corresponding to all the information we're given, and then just kind of solving for the variables. Maybe there's a more direct or elegant way of doing it here. But we did end up getting an answer in the end, 181. Could be wrong. If I find an error, or if I have more to discuss about this problem, I'll write it in the description. Otherwise, thanks for watching.